We are Project It's Personal, a Myers-Briggs machine learning project, with Tristrum Tuttle,
Chiu,
and Sheetz.
MBTI types were developed as a way to differentiate between character traits amongst humans. MBTI types are defined along 4 axes: extroversion versus introversion, sensing versus intuition, thinking versus feeling, and judging versus perceiving. These MBTI types provide interesting insight into human behavior and are actually being used more and more prominently in the workplace to help managers form teams that work well together on a personality level. Ray Dalio, the founder of the hedge fund Bridgewater, uses MBTI and other personality tests to help his employees understand themselves and respond better to conflicts.
Our dataset was from Kaggle and contains 8,675 instances of people's text posts and their MBTI types scraped from an online forum called Personality Cafe. In total, there are 16 personality types, and for our purposes, 16 different labels. The text for each instance contains the last 50 things a person has posted separated by 3 vertical lines. We used a Python script to add the IBM Watson emotional features to the dataset. The emotional features we included were anger, joy, sadness, disgust, and fear. Each emotional feature is represented by a score from 0 to 1, corresponding to how likely the text is to convey that emotion. We cleaned the text data by removing the text post break characters and URLs. We decided to leave punctuation, capitalization, and emojis in place because they imply certain types of emotion in IBM Watson.
We examined the emotional scores of our IBM-generated features and found that while there was some correlation between the scores of anger and disgust, and also between sadness and fear, for the most part, the scores were independent. The label distribution varied widely, however, with some MBTI types having almost 20 times the representation of others.
For the classification part of our project, we made a naive Bayes classifier using word vectors representing each of the blog posts as features. This resulted in a 50% training accuracy and a 38% testing accuracy. We also made a logreg SVM random forest classifier using IBM Watson emotional scores as features. We tweaked the hyperparameters of the models to find the best performance. Among the 3 emotional score models, based on our performance results, the logreg model is the best model.
We built 2 generative recurrent neural nets to attempt to generate MBTI blogs artificially. The first, a linear RNN, was not very successful. The second RNN used the GRU layer and was much more effective at generating realistic blogs. Here you can see the cross-entropy loss of our GRU RNN, which was able to produce sentences like, "I have a little," with that how to make term of person, and much done. Although this sounds like gibberish, it is impressive that our model was able to learn completely accurate English words, despite it learning at just the character level. Finally, for some additional analysis, we tried using LDA categories to improve on the accuracy of our emotional scores model without needing as many features as naive Bayes. Unfortunately, even for 50 categorical features, we were unable to improve the training accuracy by a notable amount. For fun, we also tested our best classifier on our own writing samples. It was surprisingly accurate, guessing both Hannah's MBTI type from a collection of her text messages and correctly classifying 2 out of 4 RNN-generated blogs.
Training data is inherently biased with respect to the way different kinds of people communicate. Companies are becoming more and more dependent on algorithm screening of candidates. If candidates are rejected solely based on algorithmically generated personality types, the company may miss out on very highly qualified candidates. Finally, people often have different strengths in their work versus their personal lives. Classification based on personal communication may not be reflective of how someone would behave in a workplace environment.